Main thing about this is, okay, there's another jump. I won't say which is jumping, whether it's that or this. Okay, so how to get rid of the PC? Well, first play around and find some software that you can first use in the, let's say, Windows environment and in Linux environment. Then take a Raspberry Pi 2 or 3, but don't take a Raspberry Pi 1, A, B, C, D, whatever the number is. It doesn't have enough processing capacity. Take a Raspberry Pi 2 or 3, put in their standard operating system. Don't play around with anything else. I've done it. Of course, you can do it. But use the standard Raspbian operating system, which of course is free, and all the updates are free. And you should have a working non-PC SDR application. And as I said here, it's initially that's what I did. And as long as I only configured in 2 of the audio paths, let's say the audio input from the receiver and the audio output to the sound card, everything works fine. So lovely receiver, you can tune it and it works fine. There are a few clicks and pops occasionally. As soon as you configured in the TX paths as well as the RX paths, then fundamentally it doesn't work with my physical configuration. Remember, I've got one USB port coming from this box. There's a hub inside the box. Why didn't it work? The processor was not overloaded. According to the Linux processor load figures, processor was fine. It's 2 of the cores were running with 40-50% of load, 27%, 50%, something like that. If the Ethernet interface was up, because the Raspberry Pi has a 100 base T or 10 base T Ethernet interface, if that was up, there were also clicks and pops in the receive. And basically it is USB bus performance issues that stopped it working well. And this has sort of been well reported by many audio enthusiasts who of course have taken Raspberry Pis and tried to build mixers and this, that and the other with them. And QUISC has 4 audio streams, at least 3 of them running at once, because QUISC has Vox control. So whilst you're receiving, it's also looking at your microphone input to determine if it should go into transmit mode. So just adding the one audio stream was enough to sort of break the Raspberry Pi USB subsystem. So how to interface to Raspberry Pi? And what was the real problem? Okay, it has 4 ports of USB available. It has a connector where you can put audio cards directly onto the processor and use parallel bits between the audio card and the processor, not using USB. That's a possible solution to USB overload problems. However, the USB Raspberry Pi interface is not the same as that's found on a normal PC. The Raspberry Pi chipset is a chipset designed for mobile phones and other mobile devices, and it doesn't have a full implementation of the USB, we call it master interface, the PC side of a USB interface. in the hardware. It does have a full implementation when you take their operating system, but much of the implementation is done by extra software, making up for the lack of the hardware. And the extra functionality has the special driver software, and there are internal driver issues. And it was very easy to see that with the using the internal hub in this device and connecting it to the Raspberry Pi, you could easily see in the error logs that lost packet here, lost packet there, lost packet here, lost packet there. So the problem was the lost packets. But why? So what you can see here is that there are three interfaces inside this transceiver controller. There's the SDR itself, which has one high-speed interface running at 96 kilobits per second, in and out. There's the audio interface running at 48 kilobits per second, in and out. And there's a USB interface on the control card for sending dial frequency data and mode data and stuff like that between the computing box and the hardware, in and out. So there's three USB interfaces. They go into a hub and then off to the PC or Raspberry Pi or whatever it happens to be. Not all of those interfaces are USB 2, some of them are 1.1. And when you have 1.1 interfaces, several of them, then you have to have what's called a transaction translator to convert it to USB 2. Cheap USB hubs and expensive ones are often poorly specified, or actually not specified at all. The spec is USB 2, 4 ports, end of discussion. External power supply, maybe, might be specified. The hub that I used in this was something I bought that was physically a nice format to fit into the box. It had a common connector on one side of the PC board and three other connectors on the other side of the PC board, so it was easy to mount into the box. It was also one that has only one transaction translator for the whole four of the interfaces that are on the downside of the hub. The hub used in the Raspberry Pi itself, remember it has four interfaces on it, 4 USB interfaces. It is a multi-TT hub where every interface has its own transaction translator. The transaction translator converts the speed and the format, but it does buffering and negotiates with the upper level controller, are you ready to take some more data and stuff like that. Raspberry Pi doesn't work well if you put a single TT hub below it. So, solution to the not working QUISC on the Raspberry Pi. Use the internal Pi USB hub. It's multi-transaction translator. It should work well. Well, it did. Works perfectly well. The only thing then is that if you've got a box like this and a separate Raspberry Pi, you need 3 cables going to it. Use an external multi-TT USB hub. Would that fix the problem? There are plenty of people, including, for example, Cirrus Logic, who make multi-TT hubs. It's just that they're not, you can't find out in most cases in the cheap USB hubs or expensive ones, are they using the multi-TT hub or not? And I must say that in Europe, not just Finland, but in European suppliers, they don't seem to ever specify. And if somebody can tell me I'm wrong, please tell me and I'll buy things from them straight away. They don't specify. Do their USB hubs have multi-TT capability or single TT capability? But in US it seems to be different. There are people who supply USB hubs where they say multi-TT USB hub. Just buy it through eBay or directly from the supplier. You buy it from eBay and you get the single TT hub. And this device has been modified to have a multi-TT hub inside it now. So here I take the Raspberry Pi and the USB interface out of the PC, plug it into one of the ports here. So this consists of the Raspberry Pi computer itself, plus the screen and controller, and we plug the power supply I'm sorry, it's a small screen. I could have perhaps got it to run on the HDMI and put it on there, but then we would have had another demo effect, I'm sure, which I don't know what it was. This is the Raspberry Pi booting up Linux. It's now coming up to it's gone through the sort of verbose part of booting it up, and then it'll come up to the normal screen. After some seconds. Yes. And there's the normal screen. And here we have Quisk. And I must say that I'm not, okay, I can cheat. I've got a mouse here too. It's connected to this. And it seems that with a mouse I can click fast enough to activate the program. And here we have Quisk running on a Raspberry Pi with transmit and receive paths configured in, and it's receiving the same signal that we were before. So it's possible to make it all work, but you have to spend a lot of time on the internet, you have to read a lot, and not give up in the middle. And the last slide I've got here is what I say is continuing story. The touch screen seems to work pretty well. For example, as long as I'm tuning inside the screen width, it's easy to use the touch screen. Of course, even when I do the software and I just turn the knob, then it's easy to tune it using the knob too. Running upper level software on the Raspberry Pi, I personally haven't tried it yet, but I've communicated with a couple of other hams who are interested in the same strange way of receiving amateur radio signals. And it seems that people are able to get FLDigi and possibly other software running fairly well on this thing. So you can, in principle, throw away the PC, provide 5 volts at 1.5 amps or so, and then you've got a full controller for it. The thing that doesn't work very well on this current software implementation is that if you want to make large frequency excursions outside the range of what's on the screen, it's quite difficult unless you use the mouse, because touching the numbers here, you can get them to move in the downward frequency direction. But it's very hard to get them to move in the upwards frequency direction. Whereas if you, wrong mouse. If you're using the mouse with this, then you can just pick a digit, you probably can't see, and then you can use the roller, and you can roll it wherever you like, including outside the screen, and then it'll move a screen full to the next frequency list. So, if you're interested in this sort of operation, I think it's quite possible to spend little money and use a lot of time in playing around with this stuff. Of course, you might want to have contacts with people as well, but you know, that's another thing. Okay, thank you very much. If you have any questions or discussion or comment, then I'm here for a while. Yes.
A question. Have you ever thought about changing your first name?
Why?
Because Hamish is kind of diminutive for your
but Hamish, which is the right name,
I don't know.
It's an old Scottish name, and I'm named after my father's brother. So Hamish is a Scottish version of James. So in Finnish, I'm James. Okay.
Thank you.
Yes.
Question: how well have you these things documented? Because you say you'll spend a lot of time on these things.
Funnily enough, I have a small PDF that says what the recipe is.
Because I sometimes try to do these things, but then I have too many parallel things
Yes.
running, and then usually it's just a daily, you know. But it's quite a. Of course, you learn a lot while looking at the
Yes.
different things.
What I've tried to do is actually write down most of the key things as they've been going along, because my memory's not so good anymore, and you know, it might be useful for somebody else as well.
Right. But that's the question: that is it something that somebody else could take and?
Certainly, I'm sure, yes. Yeah. And at some time soon I hope to put it up on my ham radio website, so anybody who wants it can have it. Okay, if there are no more questions, then thank you.